Hey everybody, this is Mr. Schaefer, and I'd like to welcome you back to another riveting episode of a video podcast on solving quadratic equations. So here's our list of the 5 different ways we can solve quadratics. We've looked at all of them, most all of them in the last couple weeks in this semester. We've focused on parabolas and quadratics this whole second semester of Algebra 1, and we're going to come back and look at factoring and square roots and graphing, and again, the quadratic formula. Completing the square is going to be that extension method that we'll save for another time. But I want to just see if we can select which method is used best when we see these quadratic problems and these equations to solve. So here again is that nice list of each method and then when we should use the method. Don't forget, quadratic formula can work and will work whenever you want on any kind of quadratic, as long as that quadratic's in standard form. And so it's with those ideas in mind that I'd like to look at this activity with you today. It says warm-up worksheet. It's really more of a review than it is a warm-up. And just a reminder of the methods, they're listed here, and I've categorized the series of questions and organized them by method. So in the first box, we see all these different factoring problems. If we move down the worksheet, we have a box of problems that has that are square root problems. On the back side of the worksheet, we see graphing and quadratic formula. So the idea here is that we're going to be using a variety of methods of solving quadratics to actually attack these problems and solve them. So we're going to begin with the factoring method. I'd like to do maybe 1 or 2 examples with you per section. So to solve by factoring, don't forget to look for that GCF first before we do anything else. In number 1, I see a GCF of 5a. So if I factor out a 5a, I'll be left with a plus 4. Undistribute that 5a. And then don't lose your equation. Carry down the equal 0. With factoring, we're going to use the zero product property. So either 5a is equal to 0, or a plus 4 can equal 0. So my solutions will be 0 divided by 5. And we'll get a equals 0, or over here, a must equal negative 4. So there are my 2 answers from solving by factoring. And they can get a little bit tougher than that. So in number 4, this one is a trinomial factoring problem. There's only one way to get a 3x squared, so 3x times 1x, how about that? And now I need numbers that multiply together to negative 5, but when we add them and pair them up with the 3x and the 1x, we get that middle term of a negative 8x. So what if we try a 1 and a 5? If we pair them up, check inners and outers, I'm going to have a 1x and then a 15x, way overshooting that negative 8. So what if I reverse it? Fortunately, there's only one way to get a 5. We can just do, it has to be the factors 5 and 1. And this might do it here. So 3x minus 5, and then x minus 1 if you check inners. Check outers, add them up, and we get negative 8x, which is the match for the middle. So I factored this correctly. Don't lose the equal 0 on the outside there. And then, same thing, the zero product property. Either 3x minus 5 is equal to 0, or x minus 1 is equal to 0. So we will solve each one of these. Looks like positive 5/3 is one solution, and then x equals positive 1 is my other solution. So there we go, solved by factoring. Switching gears here to the square root method. This is maybe my favorite method. I like drawing radicals and using plus or minus. Don't forget to simplify the radical if possible at the end as well. So we'll kind of look and see if these problems have anything fishy or kind of funny about them. So let's begin with maybe number 9, actually. We'll start here. So negative 3x squared, what if we subtract 4 from both sides? Because we want to isolate the variable squared. Get x squared by itself. Now, how about we divide by negative 3? It's a coefficient. We can divide both sides by that number. So I'm left with x squared equals negative 3 divided by negative 3. Positive 1. We can take the square root of a positive number. So if I square root the left and the right, we'll have x, because the square root cancels the squared, like that. Regular x equals the square root of 1. The square root of 1 is simply 1. But don't forget, when you take the square root, we need to write a plus or minus on the number, on the radical. So two answers there, positive 1 and negative 1. Let me jump up here to number 7. There is no way to simplify radical 74. I'm going to just root the left and the right. So regular x on the left equals root 74, but don't forget, plus or minus, like that. And then just leave it as plus or minus root 74. There's no way to simplify it. If my answer was something like root 12, that we could break down into a root 4 and a root 3. So you could write that as a plus or minus 2 radical 3, because radical 12 could be simplified. But in this case, just plus or minus root 74. And finally, a quick reminder, look at number 8. Divide by negative 3. We'll have x squared equals negative 2. And when I go to do the square root step here, we cannot have x equals the square root of a negative number. That is not possible. There is no real number that exists. You cannot take the square root of a negative number in the real number system. So we're going to say no real solution. There is a solution to that equation, which you'll learn about in Algebra 2. But more on that to come. For right now, we're just going to say that there's no real solution for that quadratic. Enough with square roots. Let's go to graphing, which is the next piece of our review here. And it says here to use a calculator, use Desmos.com. I might agree here to use Desmos. I kind of like that feature pretty nicely. We're going to look for x-intercepts when we graph. Look for x-intercepts. So to solve the quadratic equations by graphing, where do the functions essentially hit 0? So if I look at number 10, right here, I want to know where are those x-intercepts. So on Desmos, or maybe on your graphing calculator, you'd want to graph x squared plus 9x minus 3. This would definitely be a calculator problem. And according to my notes, the parabola looks something like this. You can double check that on a graph. There is a negative x-intercept way out there. We call those zeros, or we can call those solutions. We call those roots even. There's also a positive x-intercept. And those x-intercepts are the solutions that we're looking for. When y equals 0, that's basically looking for the x-intercepts, which we call roots, which we call zeros. There we go. And I believe this answer you can check again. Negative 9.32 is that negative intercept, and then positive 0.32 would be that little x-intercept on the right. And then don't write those in parentheses. It's not an ordered pair. It's not an x comma y value here. Those are both x coordinates or x values. So x equals those numbers. Finally, let's end with the quadratic formula. Just a few more examples, and I think we can do no better than to actually write it down here on our paper. X equals the opposite of b plus or minus big square root over, or big square root of b squared minus 4ac, and all of that is over 2 times a. So you really need to have that quadratic formula memorized if you don't have it already memorized. There it is. Let's see how that might look in a problem down here below. And I think maybe we can try, how about a problem like, let's do number 12. Number 12. Don't forget standard form is how we begin. So let's add that 8 to both sides so that we have our equal 0. Standard form. A is 1, B is 6, and C is 8. So formula, x equals opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2 times 1 in this case, so just 2. And if I look in the radical, it looks like I'm going to have 36 minus 32. 36 minus 32 is simply 4. So negative 6 plus or minus the square root of 4 all over 2. And the square root of 4 is the number 2. So negative 6 plus or minus is already in the formula for me, which is nice. All over 2. Now, that's going to lead to two different numbers. We got to make sure we get them both. I'm going to draw a little double arrow here and branch off. Up here, we'll do negative 6 plus 2, all divided by 2, or negative 4 divided by 2, which gives me negative 2. Don't forget negative 6 minus 2, all over 2. Negative 8 in the numerator for an answer of, that'll be negative 4. So negative 6 plus 2, all divided by 2, and then negative 6 minus 2, all divided by 2. These are my answers, negative 2 and negative 4. Now, sometimes we might need to do some simplifying. In number 13, I'll maybe just wrap up with this one here. So standard form, once again, 8x squared. Let's see, why don't we add 6x will be plus 13x equals 0. The c value here is a 0, so x equals opposite of b plus or minus square root of b squared minus 4ac, which is a 0. There's no c value, all divided by 2 times 8. So this is going to become negative 13 plus or minus the square root of 169 divided by 16. And now we're kind of back where we were over here. We can separate that, branch it off into two branches, and find the two solutions. All right. So, by the way, there is an extension down here for completing the square. Like I said, we're going to wait with that one and just kind of postpone that for another time. Watch out, by the way, as I'm thinking about it in the quadratic formula, whenever you get a negative discriminant, a negative number in the square root. So if I have my number, well, here, let's look at 14. I'm going to get standard form first of all. So what if we subtract x squared? There we go, 2x squared and plus 3x, and subtract 8 gives me plus 9. Opposite of b, plus or minus square root of b squared minus 4ac, all divided by 2 times a. It's really what's in this radical that I want you to pay attention to here. Now I have 4 times 2, which is 8, and then 8 times 9 is 72. So in my square root, I have 9 minus 72. That'll be a negative 63 in the radical, and I'm pretty much done right there because, again, no real solution. You cannot take the square root of a negative number and have a real number answer, and when that happens, we stop, we're done. This has no real solution. All right, so there's a pretty good review of all the methods. My goal for you, my objective for you would be to look at various quadratic equations and determine which method you think would be the best one. And often multiple methods will work just fine, but kind of looking back at the variety of methods, make sure you're familiar with how each one works and when it would be best to use each one. Thanks for watching.